Every password you type, every private message, every search you immediately delete because you reconsidered. The keyboard application you installed to get better autocorrect, or a fun theme, or swipe typing has been observing all of it. And in a significant percentage of cases, it hasn't been keeping that information local. It's been transmitting keystroke data, context fragments, and learned vocabulary to remote servers owned by companies you've never researched, under privacy policies you never read, across jurisdictions whose data protection laws vary wildly. This is not a theoretical concern. This is the default behavior of several of the most downloaded third-party keyboards on both Android and iOS, and the mechanics of how it happens are not hidden. They're just not advertised. Let me walk you through exactly what's happening, what the data actually contains, which design decisions make this possible, and why the usual defense, the one where someone says your keyboard can't possibly be sending everything, falls apart once you look at the architecture. Start with how a software keyboard is built. On Android, it's called an Input Method Editor, or IME. On iOS, custom keyboards operate under a sandbox that requires explicit user permission for what Apple calls full access. The moment you grant full access, the keyboard extension gains the ability to make network requests. Without full access, it cannot send anything. That single toggle is the gate. And keyboard apps absolutely beg for it, because the features that depend on it, cloud-based autocorrect, shared learned dictionaries across devices, GIF search, cloud clipboard, translation, theme downloads, are the features the app is marketing. Here's the part people miss. Once full access is granted, the keyboard does not have to ask again. It does not have to notify you when it's transmitting. The operating system doesn't display a persistent indicator for keyboard network activity the way it might for location or microphone access. Your keystrokes flow through the IME layer, get tokenized, get buffered, and then the keyboard's own code decides what to do with them. What that code does is entirely up to the vendor, and the vendors include companies based in jurisdictions with minimal enforcement, companies with histories of data mishandling, and in several well-documented cases, companies whose keyboards have shipped with outright vulnerabilities. You may remember the AI at type incident. In 2017, an unsecured database belonging to that keyboard's parent company exposed personal data from more than 31 million users, including phone numbers, locations, email addresses, IMEI identifiers, and in many records, what looked like typed content or dictionary entries harvested from user devices. It was a configuration failure, not a breach in the traditional sense. The data was simply sitting on a public server with no authentication. The scale of that leak told you something deeper, though. The keyboard had been silently uploading that data in the first place. Then there's the Swift KeySync incident from 2016, where users logged into their Microsoft accounts and began receiving email address suggestions from strangers. The cause was a back-end synchronization error in the cloud learning system, which at that time kept a personalized language model derived from user typing. Microsoft paused the Cloud Sync feature while they investigated. That incident was minor in its real-world impact, but it confirmed, in the clearest possible way, that what you typed on your phone was being modeled and stored on someone else's infrastructure. More recently, security researchers documenting vulnerabilities in mainstream Chinese-developed keyboards identified a series of flaws. The Citizen Lab, in an extensive 2024 analysis, reported that keyboards from Baidu, Tencent, iFlyTek, and others transmitted keystroke data using weak or broken encryption, allowing passive network observers to decrypt what users were typing. Citizen Lab estimated roughly 1 billion users were affected across the keyboards they examined. The researchers called it a cross-vendor systemic failure. These were not obscure apps. They were defaults on hundreds of millions of devices. Now ask yourself what the keyboard sees that the operating system does not. When you type your banking password into your banking app, the app receives the text. It encrypts it and sends it to the bank. Good. Standard TLS. But before any of that happens, your keystrokes pass through the IME. The keyboard sees them first. The app gets them after. If the keyboard wants to log, buffer, summarize, or upload those keystrokes, the app has no way to know. From the application's perspective, The keyboard is a trusted input source. From your perspective, you've just handed every keystroke to a third party who happens to live upstream of every field you touch. iOS attempts to mitigate this in two ways. First, as I mentioned, custom keyboards require full access for any network behavior. Second, Apple restricts certain sensitive fields. When you focus on a password field in iOS, the system automatically swaps your custom keyboard out and forces the native Apple keyboard to appear. That is a genuine protection. But it only works for fields properly tagged as secure. Web forms on mobile Safari, in-app custom text fields that weren't configured as secure input, search bars, messaging apps, note-taking apps, authenticator setup screens. These don't all trigger the swap. The gap is wide. Android does not have the automatic swap behavior. On Android, your third-party keyboard can be active in password fields. Some keyboards implement their own incognito mode that disables cloud features when they detect a password context. Others rely on the app developer setting the correct input type flag. And many fields, even in mainstream apps, don't set that flag correctly. Let's talk about what gets sent and what it looks like on the wire. Reputable keyboards, and I'll include Google's Gboard in this category, transmit derived data rather than raw keystrokes. They send your learned vocabulary hashes, they send diagnostic telemetry, they send the payloads required for cloud voice typing or translation when those features are actively used. Gboard's federated learning approach, introduced several years ago, specifically attempts to train its language model on your device without uploading your text, pushing only model weight deltas to the server. That is a meaningful privacy design, and it's worth acknowledging. Less reputable keyboards make weaker guarantees. Some batch keystroke content and send it as analytics. Some transmit every autocomplete query to a cloud backend, which technically means the backend sees a rolling window of your typing. Some download dynamic language packs, theme assets, and sticker packs over plaintext HTTP, which is concerning for an entirely separate reason. It means an attacker on the same Wi-Fi could manipulate what the keyboard loads. Some cache recent typing in persistent local databases that any future forensic extraction of your phone would surface. The business model makes this predictable. When you install a free keyboard with animated themes, no subscription fee, no visible ads inside, the typing experience, the revenue has to come from somewhere. It comes from data. From advertising partnerships that use your typing patterns as an audience signal. From selling aggregated behavioral data to analytics brokers. From partnerships with search providers who pay for default query placement. Keyboards are an advertising surface pretending to be a utility. Here is the practical threat model. On an average day, you type into a messaging app about your health. You type a partial credit card number into a payment form, realize you typed it wrong, delete it. You search for a sensitive medical term. You enter your two-factor backup code. You write a work email containing proprietary information. All of these pass through the keyboard process. The question is never whether your keyboard could capture all of it. The question is only whether the vendor chose to, how they transmit it, who they share it with, and how long they retain it. What should you actually do? The most defensible choice on iOS is to not grant full access to any third-party keyboard, and ideally to not install one at all. The native iOS keyboard is developed by Apple, operates under Apple's on-device processing architecture for autocorrect and suggestions, and does not transmit keystroke content to external servers under normal operation. If you need a specific feature, say swipe typing, that's available natively. Apple added it to the system keyboard some years ago. On Android, the most defensible choice depends on your threat model. Gboard is developed by Google and has meaningful cloud features. If you already use Google services, Gboard does not meaningfully expand your data exposure. If you are trying to minimize data given to Google specifically, open source alternatives exist. Heliboard, Anysoft Keyboard, and Florisboard are community-maintained keyboards available on F-Droid that default to fully offline operation. They do not require network permissions. They cannot transmit your keystrokes because they cannot reach the network. Florisboard in particular has been under active development and is used by the Graphene OS and Calyx OS privacy-focused Android communities as their recommended keyboard. For users in higher risk contexts, journalists, researchers, Anyone managing credentials regularly, it's worth auditing what keyboard you have installed, auditing whether it has full access or equivalent network permission, and replacing it with a vetted offline option. Verify by checking the keyboard's permissions in your system settings. If it has network access and you cannot articulate why it needs it, that is a signal, a second layer mitigation that matters. Password managers with autofill integration substantially reduce the number of sensitive strings you actually type. When your password manager fills a password directly into a field, the keyboard is bypassed. The string never goes through the IME pipeline at all. The same is true for passkeys, which are moving toward broader adoption through the FIDO Alliance's WebAuthn standard. Passkeys don't require you to type a secret, so even a malicious keyboard sees nothing useful. The larger pattern here is one you'll see repeatedly across the privacy landscape. Every input layer between you and an application is a potential surveillance point. Your keyboard, your clipboard, your accessibility services, your system IME selection. The operating system vendors have built partial protections, but those protections exist as opt-in toggles on the user's side, not default deny on the system side. The defaults favor convenience. The defaults favor the ecosystem of third-party extensions that make phones feel personalized. And the companies providing those extensions have learned that users will trade keystrokes for themes, for emoji packs, for predictive suggestions that feel magical. This is not a conspiracy. It's a market. The product being sold is your typing, and the payment is the software that types back. What I'd encourage you to take away is not paranoia, but a recalibration of what you consider sensitive infrastructure on your device. The keyboard is not a decoration. It is the narrowest choke point through which every word you ever type must pass. Treat it as seriously as you treat the browser you use to log into your bank. Install keyboards from developers whose business model you understand. Revoke full access, or its Android equivalent, from any keyboard that doesn't need it. And if you find yourself about to type a password, a medical query, or a private message through a keyboard you haven't vetted, let that hesitation become a habit. Because the one truth that cuts through all of this is simple. The data you don't type cannot be uploaded. The permissions you don't grant cannot be abused. And the keyboard you don't install cannot send anything anywhere, no matter how attractive its theme store happens to be.